All right. Hello, everyone. This talk was a bit improvised because there was another talk that got cancelled, so we decided to talk about the lab today. We have a very simple table of contents. We are going to talk about how we were managing hardware before and why that wasn't ideal, how we're managing it now, what's Mr. Provisioner, what is the MLab, and then we're going to talk a bit about how the HPC lab works. So the old lab was a bunch of machines in a few racks in our office, and when you start building machines in kind of a meeting room in the office, it gets very loud, people complain, that they can hear all the servers. And it wasn't very efficient. The air conditioning wasn't really keeping up with the amount of machines that we had. So we decided to move out of there and into a data center. We did grow the lab organically over time. We didn't have enough power in the office for all the servers. We didn't have enough air conditioning either. And as I said, the noise was getting a bit annoying for the office. The new lab is in London. So we've hired some data center space. We have redundant power, cooling, everything that you can expect from a professional data center. There's biometric access, so we got all our finger registers so that we can go on and manage the servers. And then they do regular testing for power and air conditioning and whatnot. Whenever things go wrong, they know how to handle it better than in our office space. We have our infrastructure deployed with Ansible. So before, our infrastructure was all manually set up, and we thought that wasn't very reliable. If something was to go down, we would be in trouble to get it back up. We do have multiple VPNs. Each lab has its own set of users. This is what the lab looks like today. We have 4 racks. One has a few Ceph machines that we're going to offset to or give to the Ceph community. We have an HPC lab, which is another rack of machines. We have the leg machine lab, or MLab, what we say. That's bare metal servers for my team and all other teams in leg. And then we have the developer cloud as well next to it. We used to have one router, but now we've put together 2 so that we have a bit of redundancy there. And then each of the racks has its own VLANs so that they don't interfere with each other. Any questions about? Okay. So notice that we have switches, obviously, in each rack so that we can connect the machines to. We have 2 networks, a management network, which is for the VMCs, so that we can manage the machines. And then we have another network for testing, or for like the normal traffic between machines. And we have a top of the rack provisioner, and I'm going to talk about that in a minute. So what provisioner does? Okay, let me backtrack. The problem we had before is that we had a bunch of machines that couldn't be easily shared amongst people. So everybody was raising tickets and asking for a machine to be assigned to them, and it took a very long time. We had to give people root in several infrastructure servers so that they could upload their own images for testing, and it was all rather cumbersome to use. So we've put together a small application that manages user access, machines. It has images that people can upload by themselves, so we don't need to care about that. And it also manages the network, so it assigns IPs or it manages the HCP by a PR plugin. It is easy for us because, so say a new assignee comes to the team. So we give them access to the VPN, we give them access to this application, and then we assign a machine to them. And from then on, we don't care. They can install whatever they want on it, they can test images, they can test whatever application they want to test.
Does that include things like the kernel or initRD?
Yes, the kernel, user space, anything really. So we don't really care. We recommend that when you get a new machine, you reinstall it. I have people sometimes say, no, what's the user and password? And I'm like, no. You should be reinstalling the machine. This is your machine completely. So the way we manage machines is by talking via IPMI with the BMC. So if IPMI doesn't work in the servers, we raise bugs to get it fixed. And then it also has an API, so that whenever you're done with your manual testing and you're ready to start using the service automatically, you can upload your images automatically, you can reboot the machine, set it up with your new image, and off you go. Do you guys have questions about?
Can Mr. Provisioner manage other network medium like InfiniBand and so on?
What do you mean by manage?
Set up the DHCP.com for IV network or something.
We haven't tried it, so what it does is it uses a key plugin. Mr. Provisioner knows what the network is, and it knows the MAC addresses. So you can say to it, for this MAC address, I want this IP. And whenever it sees the MAC address, it will serve the IP to that machine. And this is good because then users can control the way IPs are assigned, and I don't need to care. I don't know how that works in InfiniBand. I don't think we have tested it.
InfiniBand needs a special identifier to obtain the IP address.
Okay, so then it won't work out of the box. We would need to enable it.
But it is an open source project.
It is. So currently it's sitting under the Linaro GitHub, which is making it difficult to manage and to get new contributions from people outside Linaro. So we're going to move not only Mr. Provisioner, but all its little services that allow the functionality, like the TFTP proxy or the console management thing. We're going to move them under Mr. Provisioner project in GitHub so that we can manage the contributors easily. So.
Thank you. I'll look into it.
All right, sounds good. Any other questions? So this is a bit of reiteration of what we've said. We need, when a new assignee arrives, we give them VPN access, we give them provisioner access, and then we assign them a machine or 2 or 3 or however many they need, and off they go. Whenever they don't need the service anymore, they can tell us, we can assign them to someone else. That's not a problem. Also, you can use the API to loan servers. So the idea is that eventually we will not be assigning machines to, say, an automatic process for testing. We will be assigning them on demand. So you would have a job that will say, okay, I need a Cavium server with this much memory. And it will search amongst all the machines. If that machine is free, it will assign it to that job. And then the job automatically installs whatever it needs and runs, and then frees the machine for someone else to use. That's the idea. I think that's pretty much it. Anything else that I'm missing?
Do we have anybody else using this?
What do you mean anybody else?
I'm leading.
So the question I had was, is anybody else using the MLab?
Yeah, I believe there are several companies within Leg that are using it that have their own version of provisioner installed. Yeah.
Right.
But bear in mind, it's work in progress. So anything that's missing can be added.
And you're looking for contributors?
Yeah. There are issues there, so the project is managed in the open. You can look at the list of issues and pick one. But please, before implementing something completely, socialize it and discuss it so that we are all in the same page when it comes to implementation. Because we don't want like massive features to appear there one day and then we don't know what to do with them.
So with these various options, I just want to check what the best solution from my use case would be. So generally, I'm just looking for a root access to a server so I can do some building and testing, but I'm not interested in keeping it around afterwards or having it persist. When I was using the developer cloud, I found that tricky to do because there's quite a lot of setup. You have to specify network and VPN and punch holes, and you need a fair amount of knowledge. Currently, the easiest way I've found of getting myself a random piece of hardware is to use a Lava job that I've set up to set it up and give me access. So is would the Mr. Provisioner approach fall in that sort of ease of use of getting a machine up that I can SSH into from the get-go?
Yeah, but you would still need to install it and use a preset. So essentially you would set it up once and then have a script that does a couple of calls to the API, and then you can reuse that over and over.
So I can have a pre-canned recipe,
exactly,
put Debian on it or whatever, and I can just go, okay, thank you.
And if you talk to Renato,
he will tell you that it's the easiest thing that he's used so far to date. But it's a web interface. You get in there, you start doing your stuff, you can pull up the console, watch the thing boot, if you wanted to do it the manual way. Because of the API, I mean, it's really, really easy to do.
Well, the other thing was, we could have gone for a pre-canned solution, but we wanted to be able to do manual testing. So manual testing is a big thing for us because it takes a lot of manual testing to get to a point where you can automate testing on the servers. So we wanted to be able to do manual testing with the UI or automatic testing with the API. So we need that solution that covered both.
So how exactly do you get access to the machines from the outside world? So that was
Via VPN.
So you need to set up the VPN on your machine when you have.
Yeah, you open the VPN and then you're inside the lab.
Right. Okay.
Yeah.
One question: are there plans for DNS for entry for internal machines?
Yeah, there is an issue there about that. Yes, there's a question behind it.
So for some applications testing, it needs multiple servers. So does this architecture support the flexible compose a cluster of server by internal networking?
Yes, so it doesn't fully support it yet, but the whole point of this, the reason why we thought about this the way it is to be able to test OpenStack multi-node.
Right. For example, for some of the testing, it may need, for example, 10 or 15 servers. At that time, maybe in rack 1 there are 2 servers ready, and in rack B there are 3 servers unused, so that you want to connect all these kind of servers in different racks.
You could have one provisioner across racks. There's nothing stopping you from doing that. And at that point, you can connect them however you want, as long as the networking is set up properly. One thing that, the vision for this is, I want to be able to grow and make the cloud smaller, depending on demand. So whenever there's not a lot of demand on the cloud, we want to be able to use the servers for testing. Whenever there is a lot of demand on the cloud, we want to put some bare metal on the cloud automatically. So eventually, we're going to be able to move machines between VLANs with provision. Yeah, so that's the idea.
So really, I think the same idea as ours, because we encounter a similar issue from customers' requirement for evaluation.
Yeah.
Okay.
Yeah, absolutely.
Thank you.
Thanks.
So I'll start with the specific, going to the general. So I'm wanting to use it for doing Jenkins builds and testing of Java and whatnot. In the general, where should persistent services stay and talk to the API, such as a Jenkins server?
What do you mean persistent services? Like Jenkins?
I'd want to reinstall Jenkins every week.
You want to do that?
I don't.
Oh, no, okay. So you can put Jenkins wherever. You can have it outside the network, at your home, or you can have it in the infrastructure server, or you can have it wherever you want to put it.
Or in the developer cloud.
Or in the developer cloud even. As long as you have the keys to open the VPN to the lab and use the service there.
Yeah.
So the developer cloud, is that, I presume that's somewhat publicly accessible?
Yes.
Yes.
Because I would like some visibility on what's being built
Yeah, so-
without giving access to the machines themselves.
So- The developer cloud obviously is in the next rack, but you are not going to be able to talk from this rack to that rack internally, because that will be like a security problem. But what you can do is have a public IP on your developer cloud that then accesses via VPN the lab.
Right. We'll talk in more detail.
Okay. Yeah.
Thank you.
Any more questions? All right, so over to Baptiste.
So, another feature of the new lab is the HPC Safe Lab. The point of the lab is to have a lab controlled by a lab able to have continuous integration of OpenHPC. And this relies on dynamically provisioning multiple clusters and installing OpenHPC on it. So, thanks to the work of Kata-san, we will be able to install OpenHPC on those clusters, and we have set up a whole infrastructure set up to actually have those clusters being provisioned via Ansible and scripts. One of the requirements for this is to also protect each cluster from unauthorized access, because we have clusters of similar machines, and those machines obviously cannot be accessed by, for example, Cavian machines cannot be accessed by Huawei people for benchmark purposes, because that would be a breach of a contract, of course. So only authorized HPC engineers will have access to their own machines, and so we need containment. So all of this is automated via Ansible, as I said. We are using upstream recipes that are put on Linaro's GitHub and GitHub in general. So for continuous integration, we use Jenkins, and we have a provisioner, as each rack does. We hook up the Jenkins to the provisioner via Ansible scripts, and we talk directly to the API. We support pre-seed uploading, initRD kernel provisioning, and all of the features required. One of the requirements for this is also being that we could be able to deploy this lab in any other location. And so we have created this whole ecosystem of scripts and Ansible playbooks to actually be able to meet that requirement. And we will also separate infrastructure into strictly OpenHPC testing and benchmark. Also, and on the other side, also benchmarking compilers and more HPC infrastructure, but not directly OpenHPC. And all of this, of course, will be automated via Jenkins, as I said, to have automated OpenHPC deployment and benchmark, and also compiler benchmarks.
Any questions? No? Thank you, Baptiste.
Well, thank you very much.